Welcome back. In this session, we are going to talk about the variable and so this slide summarizes one of the most foundational and often overlooked steps in any data science project, variable identifications. Think of your data set like a recipe. If you don't know what each ingredient is, you can't use it correctly. Similarly, if you misqualify a column or say, for example, treat an ID number as a numerical value, it could distort your entire analysis or model performance. So let's walk through this pyramid of variable types. At the top, we have target variable. This is what we are trying to predict. It might be churn, yes or no, fraud or not fraud, or something like customer lifetime value. Everything else revolves around this. Next are numerical variables, which can be either continuous like income or discrete like number of transactions. These are the ones we summarize with means, standard deviation and histograms. Then we have a categorical variables split into two flavors, nominal like gender or a state and ordinal like satisfaction level or credit rating where the order matters. The next level is datetime variables. These are the key for a time-based trends, seasonality or some lag features, but only if you parse them properly and don't leave them as a plain strings. At the base, we have identifier variables, things like customer ID or invoice number. These are unique for each row and hold no analytical value for modeling and but are often mistaken as numerical value by default. So we may drop them or we may not even use them. So the understanding this hierarchy is crucial because it influences everything that follow, from type of plots we use, how to encode variables, and what kind of transformation we apply. Getting this step right helps avoid mistakes and set the stage for smart structured EDA. Once we have identified our variables, the next step is understanding the subtypes. This isn't just a theoretical exercise, it has real consequences for how we explore, transform, and model the data. Let's look at two main categories, numerical and categorical, and their respective subtypes. First, numerical. In numerical, you have something called continuous variable. They can take any value within a range, right? Think of like height, income, or temperature. You could keep zooming in on decimal places forever. Next is discrete variable. On the other hand, are typically count based. For example, you can't have 3.5 transactions, right? You can have 2.7 children. Age is a borderline example, recorded as a number, but practically discrete even in a whole years. Next is categorical variables. So within this we have got two subcategories, nominal and ordinal. Nominal variables are unordered categories like gender, country, or product type. There is no meaningful sequence between the values, right? But whereas ordinal variables have inherent order, but the difference between the levels aren't numerically meaningful. For example, credit rating might go from low to medium to high, but that doesn't mean high is 3 times better than low, right? But there is a order in between them. Each of these subtypes dictate how we visualize our variable, whether we want to use a box plot or bar chart, or whether you want to encode, whether you want to go for one hot encoding or label encoding, and how do we summarize it statistically. Misclassifying this, even a single column, like treating an ordinal feature as a nominal, can significantly impact your model performance and interpretation. That's why spending time upfront to classify variable types accurately and intentionally is core part of our EDA process. In the next slide, I am going to walk you through the Jupyter notebook where we take a banking data, where we are going to see the data from the companies which went bankrupt, and then we are going to perform EDA on the company data set, so that our main goal eventually is to predict if a company can go bankrupt or it won't go bankrupt. So before we see the EDA and then variable identification, let's understand the data set. So I'm using a Kaggle data set called Company Bankrupt Prediction data set. This is from a Taiwan Economic Journal, which has got data of companies that went bankrupt from 1999 to 2009. So we'll be using this data set for our EDA, and then I'll be giving the link of also this data set in the video comment, so you can also download this data set. And I will be having all the notebooks for each of the step. I'll have a different notebook just to segregate properly, and then all these notebooks are also uploaded into the GitHub, and then you can also download the notebook from GitHub. So to start with, we'll just use read the data, see like what is the data shape. You can see that it is having 6,819 rows and 96 columns, like a lot of features. We will also see like how we will do a feature selection using this, whether we need so many features of the data, right? Next, we will check the what is the data type overview, like how many columns are there, what are the data types, how many null columns are there, not nulls are there. So we will do this now. This will tells you that there are total 96 columns and then 6,819 rows, and then out of which you can see that the float are 93 columns are float, 3 columns are integer, right? And then we could see like luckily we don't have any null count. That means we don't have any values without any kind of missing values are not there in data set. So that's one good thing, but it tells you like how many what is the variable types, so the float, integer variable types. Next, we will identify the target variable. So what is a target variable? That is something we are trying to predict, right? In this case, our target variable is bankrupt, that the company goes bankrupt, yes or no, right? So that is what we are trying to see. And we are also trying to see how many continuous variables are there, how many discrete variables are there, how many binary variables are there. So by using this pandas code, where you can actually go through this code by simple code, you can go through this, we'll identify what are all the continuous, what are the discrete variables. Now you can see that the target variable is bankrupt. It takes two unique values, so 1 or 0, whether bankrupt means 1, 0 means no bankruptcy. And then we also have some two binary variables, something liability asset flag 0 or 1, and then we are having integer variables 3, float are 93. We are having 93 continuous variable and 5 discrete variables and 2 binary variables. And then we'll also, by looking at the column names, we want to identify some of the identify the variables by their unit or the scale based on the column, because some columns are having growth, turnover, percentage, some currency. So maybe it makes sense to see like what these variables are actually, whether are they ratio variables, are a percentage variables, are rate variables, are growth variable, like that. So we can actually look into each of this column. Now we can see that we are having 3 percentage variables, we are having 10 rate variables, then we are having ratio variables, and then growth variables. And then next we will actually categorize these variables by measurement level. Are they bounded or are unbounded? That means they're having a fixed range, or they need not have any fixed range. Now we can see that the measurement levels bounded and unbounded, like sample variable. It says range means I'm also going to talk about range in the coming slides in the next session. But you can see that what is the minimum value, what is the maximum value, and whether this variable is a bounded or unbounded. So in the end, we are going to summarize all our variable identification. Like the target variable is a bankrupt, yes or no. What are the flag variables? What are time-based variables, like operating profit growth rate, or what is a bounded or unbounded characteristics of our variables? How many of them are naturally bounded, and some of them are potentially unbounded. So as of now, we just looked into our data. What is this data contains? How many rows? How many columns? How many of them are integer? How many of them are float? Any time-based variable, bounded, unbounded? What is the target variable? That means we got a basic idea of our data. We have identified our variables. Now in the coming sessions, we need to go deep into understand what meaning these variables carry. Like for example, I'm having 96 features. Do I need all the features? Can I really drop some of the features, because I don't want to overload my model with so many features, so that which might lead to overfitting or underfitting, right? So I want to understand these 96 features in more detail in the coming sessions. So that's what we'll be doing in the coming sessions. So in the next session, we'll be doing univariate analysis. See you again in the next session.